So we are in the section on water governance issues in sustaining the commons. We talked about water scarcity, water abundance, and water distribution. The big item on water management, of course, is water governance is also water pollution, which is a very big part of how humans use water, and I am not getting the pointer. So one of the challenges of water pollution is that the polluter often doesn't experience the consequences of the pollution because the water carries it away, usually towards someone else. So we are talking about some kind of a system where you have an upstream user and a downstream user, and upstream user is not very careful, and the pollution that the upstream user creates is going to flow down to the downstream user. Of course, we should be saying users, upstream users, and downstream users. This is a classic form of a negative externality. The polluter gets the benefits of the activities leading to pollution, while the population living where the pollution ends up experiences the cost of the pollution. To illustrate this point, we examine the widespread problem of eutrophication, which I have podcasts on elsewhere. Eutrophication is when the nutrients, let's say from all the agricultural urbanization, deforestation activities on the Mississippi River watershed, wash down into the Gulf of Mexico. When you have excess nutrients, you get massive phytoplankton bloom, the photosynthesizers in the water, and if there is enough light and nutrient becomes available, they bloom like crazy, and zooplankton tend to graze down or eat up the phytoplankton, which happens also near the surface, so that what falls below the surface is typically already digested and recycled nutrients, which have to be recycled back into surface nutrients and so on. But if the bloom is so fast that the zooplankton cannot keep up with the grazing, or they waste the photosynthesized food, let's say, that photosynthesized hydrocarbon is going to fall below to the bottom or along the way, and there are aerobic microbes which then respire it or eat it up, and these aerobic respirators need oxygen, so they consume the hydrocarbon, they take up oxygen to survive, and they release CO2 from the hydrocarbon. So the oxygen uptake can get so large because the food is available is so large. Microbes just multiply and grow to consume the food. Then they end up producing hypoxia and anoxia, so the concentration of dissolved oxygen in the water can fall below something like 5 milliliters per liters, and that's hypoxia. And if it falls below 2 milliliters per liter, then nobody can live in it, then it becomes anoxia. So this is typically how it looks. This is showing in milligrams per liter, but you can do it in many units. So dissolved oxygen here, you can see the scales going from 7.51 to 8 down to basically 0 to 2.5 or so, or 0 to 0.5, not 2.5. So all the red places are where you have severe anoxia. Those fish that can move away will move away, but if you have crabs and shrimps and shelled animals that are not able to swim away, will end up dying, and many of the small fish cannot get away fast enough, so you can end up having massive fish kill. So even before all the agricultural activity, Gulf of Mexico had a natural seasonal anoxia, hypoxia, because a lot of the rain on the watershed would bring down nutrients and create anoxia. But now we have exacerbated the situation not only in the Gulf of Mexico but pretty much along all the coasts in the world. So this is the water pollution issue that is natural but severely exacerbated by human activities, and it has the upstream downstream calculation here. People who live on fisheries, crabbing, crawfish, which is very famous in this area, end up paying a huge price. So this is a Mississippi River sediment plume entering the Gulf of Mexico near the Southwest Pass. So the Mississippi Delta is a big one. It's a very productive soil for agriculture, But obviously, if you have a lot of urbanization, then the sediment just washes into the ocean and creates a lot of problems in the coastal regions as well. Okay, so there's a lot of data showing that this is getting worse and growing in size and intensity. So this example illustrates a fundamental challenge with different levels of social organization. Specifically, this problem cannot be addressed by individual farmers talking with individual fishers. So we are talking about the farmers which are spread all the way to Minnesota in terms of using the Mississippi riverbed or the floodplain to do tremendous agriculture, growing lots of important crops like corn and so on. And they don't even see, they can be so far upstream that they don't even see the Gulf of Mexico. It's the same for many water bodies, including Chesapeake Bay and so on. And they don't even know what is happening to the fishermen. So this is a fundamental challenge of how social organization can completely remove you from your own impact. So you have a negative externality in the sense you are fully benefiting from the water availability, agriculture, increasing the yields with excess fertilizer and so on. Higher level organizations must be part of the solution. How can farmers get incentives to reduce the use of fertilizers? Who will compensate fishers for the loss of productivity they suffer? If states are in charge, then why will Minnesota pay somebody like Louisiana or Alabama for fisheries problems, right? Or Texas, whoever. Dead zones can be reversed. This is good news. The North Sea had a dead zone in the 1980s and 1990s. A special organization was created that included all countries in the River Rhine basin. Due to this higher level coordination, policies were implemented and enforced to reduce sewage and industrial emissions. The nutrient inputs were reduced and the dead zone disappeared. Dead zone disappeared. So there is a governance issue for water pollution that actually got solved by coordinated multinational, multi-level governance. Unfortunately, this is not always the case. If the dead zone is an entire lake, for example, it may be the case that it cannot be restored to clear blue state. Okay, this is the case. Lake Victoria went, so far down the pollution route that many of the fish simply disappeared, but new rules, regulations and agreements actually did make a difference, and many of the fish have come back, but it's not at the original state before, let's say, in the 19th or early 20th century. Okay, so let's leave that there. Before going to the critical thinking and key questions, I wanted to include this report here by all these organizations on using indicators for improved water resource management, guide for basin managers and practitioners. Okay, so I also have additional material from another report on how climate change is affecting water and children, which is very important as well. Example framework of good water governance principles. So this is very relevant to the chapter we are discussing. So water governance is the main goal. You are looking for efficiency, trust and engagement, and effectiveness. All right, so here in efficiency you have need of data and information to manage early warning systems and so on. Financing is very important, as we discussed in adaptation, for example. Regulatory frameworks to reduce use, regulate use, water pollution and distribution. Innovative governance may be needed, as we discussed in the case of the North Sea anoxia that got solved by multi-level governance structures. And under trust and engagement, you need integrity and transparency so that the stakeholders and multiple users, upstream, downstream, and so on, believe that they are playing a fair game with others and there is no hidden social dilemma that's not being fair to them. Stakeholder engagement then obviously follows from that. Trade-offs across users, rural and urban areas, and generations. As urbanization happens, often rural areas are encroached upon, agricultural land is taken up, and It's not just occupation. Sometimes farmers are paid off to sell their land to expand their urban centers, but then the water sharing issues between rural areas, agricultural or not, and urban centers becomes a serious issue, and this plays out pretty much everywhere across the world because urbanization is still growing everywhere. Monitoring and evaluation is very important to make sure that the resource is being managed as it's supposed to be. And under effectiveness, you want clearly defined roles and responsibilities for the governance structure, appropriate scales within the basin systems where the monitoring, evaluation, roles and responsibilities, and effectiveness of management and governance happen. Policy coherence, so that if multiple countries or multiple states or multiple towns, whoever is involved, have policies that are adding up to sustaining and effective, efficient use of the water resource, common pool resource, let's say, and capacity. So the resource must have the capacity to serve all the needs and the users, and should be effective in meeting the needs in terms of the available capacity. Okay, this is a comprehensive thematic indicator framework from the integrated water resource management. So this is climate, water quality, quantity, quality, extreme events and how they affect water, ecosystems, populations, governance, technical capacity, investments needed, and water resource economic sectors. Right. So current climate, climate change, and climate vulnerabilities have to be considered for water availability, water stress, water use, demand and allocation, so quantity, quality and access kind of thing. Water quality for drinking water, ambient water quality that you are pulling from and managing as a common pool resource, pollution sources that can be monitored, evaluated and regulated, etc. And wastewater management, which is a necessary requirement for human settlements, especially urban centers, and where that wastewater waste goes, pollution goes, and how it's managed are very critical. How the water is recycled as well. Extreme events, of course, flood risk, drought risk, and management. Other extreme events could be storms, cyclones, etc., disaster preparedness. And ecosystems, land use and land use change, agriculture, deforestation, urbanization, biodiversity is important in climate change because you are going to have loss of biodiversity directly via human activities versus climate change impacts. Protected areas to deal with climate vulnerabilities, and land degradation can be an issue for ecosystems in terms of temperatures, droughts and floods and so on. There are also chronic changes where precipitation may begin to decline, or acute stresses like very heavy extreme rainfall events that we are talking about here. Heat waves can play into because the vapor pressure deficit, vegetation loss and so on will begin to matter. Demographics and health under climate change and employment can be all affected by water resources. And governance, management and cooperation frameworks, stakeholder engagement, conflict management that we talked a little bit about before, equity and gender, awareness and access to information. So it's not just water access, but information access can be critical as well, so that you know whether your rights to the water is being met or not, are being met or not. Technical capacity depends on data and monitoring, and human capacity, so investments needed for infrastructure and development, capacity investments, cost recovery, and funding sources and mechanisms. So this is a sustainable integrated water source management. The economic sectors, agriculture, irrigation, hydropower, industries, municipal sectors that serve typically commerce, businesses and households, tourism, of course, it puts heavy demand on water, and economic benefits and losses have to be tracked in terms of investments and returns on investments and cost benefit analysis, etc. Let's conclude this and then come back to the next section on climate change impact on water and children. Critical reflections here. Water governance has many dimensions. In this chapter, we have provided a simple categorization of some of the most important problems we face: water scarcity, water abundance, water distribution, and water pollution. A common challenge in solving social dilemmas related to water is power inequality. So that comes to economics and physical access. Economic access, physical access, not just uh, regulation, governance, but whether your socioeconomic status allows you fair share or not. Generally, upstream participants have easier access to water, and pollution is felt by people downstream. In order to solve these problems, higher level authorities are often needed to coordinate and mediate. Water is involved with many social dilemmas. People share common water resources, build public infrastructure to protect them from flooding, coordinate when and where to use common pool water sources, and avoid pollution that affects participants in downstream positions. Make yourself think about these few questions. Where does the water you use in your household come from? I live in Mumbai. I know the lakes and the outside reservoirs that serve the city. How much water does your household use, and what do you pay for it? What are the rates? Is it subsidized? How? What are the main sources of water use in your household, and what can you do to reduce water use? Are you taking a very long shower, running the water tap when you are brushing your teeth, and so on? Can you think of how to apply the action arena concept and the International Institute for something development? We looked at this before. Eleanor Ostrom's framework, IAD framework to the water you are using. Okay, International Association for Development, whatever it was, you can look it up. Okay, sorry about that. I tend to blank out on these sometimes, but I will look it up and mention it in the next podcast. So come back to the next podcast. Okay. On IAD is actually institutional analysis and development, the framework that was developed by Eleanor Ostrom and her colleagues over decades. So I was way off. It's not an acronym of an institution. It is institutional analysis and development, analysis and development framework. Okay, so sorry about that.